Hello, friends. I hope you all are doing great in your life. So, friends, this session I'm bringing after 51 months. So, all those folks who have been part of this journey, I would like to say a big thank you to each and every one of them. So, friends, as you are already aware that I've already provided session on SAP SD, a complete session, and I have 9,500 plus subscriber, and also 120 plus folks who have already placed in past just by watching my videos. They have confirmed officially. So to all of them, all the best and thank you for acknowledging in past. And I've got a lot of requests to basically uh, have a session on artificial intelligence. So I've already provided a session in Hindi, the same. So if anybody is interested in to basically watch this session in Hindi, so I'll put it in the description, the link for same. And also, if they want to check out in my channel, they can go and they can start watching that Hindi session. So the same session I'm repeating in English. So in this session, we are going to cover the basics of artificial intelligence. That is from a beginner standpoint. Okay, so I've got a lot of query asking that, okay, sir, tell me, is artificial intelligence going to take away our job, or how it's going to be scenario in future? So I would like to say one thing to all of them, that artificial intelligence is not going to take away your job. Okay, it is the person who is going to use the artificial intelligence. They are definitely going to take away if you are not up to the mark, or if you are not learning artificial intelligence. Okay, now coming to the new technology, because artificial intelligence is a new technology, right? So whenever in past also it's been seen that whenever new technology comes, people show a lot of resistance, right? Like your computer technology was has come in India, or even UPI. So people have different thought process, or they have shown a lot of resistance initially. But over a period of time, as there is a law also, Darwin's law, right? Survival for fittest. So you have to adapt as per the current situation or the market trend. Otherwise, you will get redundant. And this is the same which is going to happen with artificial intelligence also. Okay. So, friends, now start the session. So, there is one thing that the technology, right? So, as I mentioned in past also, there was a technology which is green revolution. Okay. It has come in India, and during 1960, okay, it started and it gained momentum in 1968. So it was a historical move, okay, and it has helped in the transformation of Indian agriculture sector. Okay, it turned traditional farming into a modern technological driven system, right? And there were a lot of advantage, and the widespread use of this high yielding variety seeds, chemical fertilizer, and advanced irrigation techniques greatly enhance the productivity. So our basically our farmers and all, they have gained a lot of advantage and everything because of this. So at that time, it was being told that how to basically use this hybrid seeds, right? So there was a group who basically heard about it, and they started implemented it immediately just after listening. Okay, and there was another group who did a proper market research. Okay, they understood about the technology, they learned about their fields, their crops, and they slowly started understanding it and then implement. So that is what happens whenever a new technology comes. There is always two segment of people, who one who just blindly follow it, and there is another who basically do a proper research and then slowly they try to uh, implement it. So when it happened, the first group who didn't do much of the research or didn't understand much, so for them, I mean, it was not very much productive. But the other group who did a proper market research and everything, understood this technology pretty well, they were trying to implement it pretty good, and ultimately the production and everything, they were actually trying to get a lot of advantage out of it. So, friends, in today's days and era, also the same thing is happening. Okay, a group of people thinks that AI will take our job. Okay, and a group thinks that AI can be helpful for our career. So, it is up to you to basically decide which group you are in. Okay, and when we talk about artificial intelligence, there are a lot of sub technologies also in it. Okay, such as learning, your deep learning, natural language processing, and then computer vision. And in all these things we are going to see in today's session. Okay, apart from that, lot of models like your agentic AI, generative AI, discriminative model, these are also we are going to learn today. Okay, so now friends, let's see another aspect of it. Also, one more thing, it is observed that whenever new technology comes, right, it has been observed that the people who basically build new products out of it, okay, they make more money. Okay, there are two set of people, one basically who does the discovery, who brings the innovation and everything, and there is another set who, or the companies and all, who basically do commercialization, and they do a lot of branding, marketing, and they take the exact advantage of that product and make money out of it. Okay, so we'll see few of the examples. So here it is innovation versus commercialization. So the gap between your invention and wealth creation reveals a fundamental truth about business success. Okay, and there are few examples we are going to see. So one example is your aviation industry. So Wright brothers built the first airplane, right? But the airlines, aircraft manufacturers, and aerospace your companies, they created massive industry that we know today, and they are making a huge amount of money. Okay, some of the example here. So, for example, your Boeing and Airbus, so these are the manufacturing giants, and a lot of airlines, your global transport networks, they have made a huge lot of profit and money. Okay. Next is refrigerator. Okay, so refrigerator was also built long back, but all the beverages company, ice cream company, hotel chain industries, so all of them have made lot of money because of this. Okay, and one more example, if I have to take, there is internet, right? So US government was basically they have come up with this internet, but then the money, lot of money, which these companies like your Google, Facebook, and Amazon, they have made lot of money because they have basically built new products out of it, and they have taken exact advantage of it. Okay, so even though internet was made by a US government, but the use of internet, right? Like for example, your Google, they have made their product. Your Meta, they made Facebook. Amazon, they made e-chambers. Okay, so e-commerce chambers. So that is what it's been seen very often. So, I mean, it's pretty often it's been seen, right? So even today, this is what happening. Whenever a new technology comes, like AI has come, right? So there are some companies, they are making the infrastructure of artificial intelligence, right? Which are very big companies. Like if I talk about artificial intelligence to basically build the model. So then some companies we can see like your Chat GPT or Google DeepMind or Anthropic, Microsoft, Nvidia, Amazon, Tesla. So these companies have created the infrastructure model. But to use this infrastructure model, we have a lot of other companies who have come. Okay, they are using, and they are basically in multiple industry segments they have come, right? So those also the industry we are going to see. So first, let's see the companies who are making the infrastructure. So before that, just the pattern rebel that we have seen, the invention, commercialization, and wealth creation. So often funded by research or government, the invention part, and then the commercialization and wealth creation part. For example, your US government, as I mentioned, they have come up with this internet, but then Amazon, your Facebook, or your other companies, right? They have actually utilized it, and they are making good money out of it. Okay, coming to the infrastructure part. Okay, the AI ecosystem who is building the future. So infrastructure and model creation. So these are powerful buildings, okay? The foundation of artificial intelligence, companies like your Google, OpenAI, and Meta creating massive language models and computing infrastructure. Okay, so some of the companies, famous company, I would just name it out. So, for example, AI chips, like your NVIDIA, AMD, your memory and storage, your IBM, Oracle, networking, your Cisco, Qualcomm, Broadcom. Coming to the AI software providers like your Google, Anthropic, Microsoft, Jasper, Meta, SAP. Okay, AI service provider, Salesforce, Oracle, SAP, IBM, uh, Tiger Analytics. So these are the companies basically they are providing the infrastructure and model creators. Okay, in cloud provide some of the cloud providers are like your AWS, Azure, Google Cloud. They are powering AI with massive computing resources. Then model builders like OpenAI, Anthropic, Meta, they are creating foundational AI models. Then comes the chip makers, NVIDIA, AMD. They are building the hardware that makes AI possible. So now the AI infrastructure and model creators, okay, and the company that uses AI infrastructure. So, for example, your OpenAI, Google, DeepMind, Meta, Anthropic, Microsoft, NVIDIA, Amazon, Tesla, these are AI infrastructure and model creators. And the company or the sector where this infrastructure is being used, like your tech companies, some of them are like Adobe and Canva. Your healthcare sector, Pfizer and Tata One MG, and then finance and the stock market, JP Morgan, Zerodha, and e-commerce and marketing, Zomato, Zepto, and Flipkart. Okay, so that is what happening. Okay, so but now let's say Chat GPT. Okay, OpenAI has created Chat GPT, but at the same time, many startup companies, right? Startup companies, they are using the same Chat GPT, right? And they are creating new products by building different use cases. So that is what is happening today, friends. So the companies basically what they did, they built the model and infrastructure, just like internet was made by US government. But the big companies that use the internet became like your Google, Amazon, Facebook. Similarly, in the era of AI, all these companies that we are seeing here, like your Meta, Microsoft, Google, Nvidia, Tesla, Amazon. So these people are developing infrastructure because they have a lot of resources. Okay, so they are developing these infrastructure, but these infrastructure are in different segments, the whether it's a healthcare, tech, finance, e-commerce, marketing, they are able to utilize it. So now let's see the um, tools. Okay, there are three AI tools, from your standalone to customized solution. Okay, so we'll see these tools and then we'll see the examples and also these in detail. So first, let's see the definition part of it. So standalone tools, so these are independent AI application like your Chat GPT, Mid Journey, Jasper, so designed for specific tasks with their own interfaces. Okay, next is your integrated platform, or integrated tool. So AI seamlessly embedded into existing software, Gmail, Smart Compose, Photoshop's AI tools, or Excel's data insights. Then comes the customized tool. So these are tailored AI built for specific business needs. Customer service bots, personalized recommendation engines, or industry specific assistance. So these are some of the examples of all these tools. So now let's see and understand these tools individually. So first is standalone AI tool. So these are some of the like companies as you can see in different sectors. So for example, in research, text, video, image, code, speech, 3D. So in all this sector, these are the standalone tool is being used. Okay. So for example, if I have to tell some of the name, then your DeepMind, Anthropic, OpenAI. Okay, these are in research. Then coming to your text, we have Outplay, your Copy.ai is there, Jasper is there, okay, and then in image, DALI is there, Midjourney is there, and then GitHub Copilot is there in code. So these are some of the standalone tool, which is basically, as the name also suggests, it does not get integrated with anything else. Okay, so for example, you use a chat gpt. Okay, so what happens there? So basically, you use a single chat GPT, right? You don't use anything else. So what happened? It became a standalone tool. So for example, let's say if I have to generate an image, okay, then I'll use daily like Mid Journey, okay, or Dali. So and my image will get generated. So such tools are called as standalone tools, where I have to get a coding from chat GPT. Then let's say if I have to go to chat GPT, it will give me a code. So my work will be done, so I don't have to look into any other tool. So that is called your standalone tool. Okay, so next is the next type of tool is integrated tools. Okay, so for example, your Google Docs, Google Slides. Okay, these are some of the example of your integrated tool, and also one of the classic example is your Netflix. Okay, so for example, let's say if I use Netflix, then basically in Netflix also AI is integrated. Okay, when you go and watch some movies in Netflix, there is a recommendation model which works there, right? You see that a lot of movies comes in your recommendation. Okay, or let's say if you go or shop in Amazon, right? So Amazon is just a website or a mobile application, right? But as soon as you go get into the application, the recommendation model starts there also. Okay, if you see a particular product, it will always be shown again and again, right? And even if you go to different social networking site, let's say Facebook and your other sites, then it will basically show the same product there also. Okay, so basically, these are called as your integrated AI tools. Okay. The third type of tool is your customize. So we'll see that also here. So as I mentioned, some of the companies, let's quickly check out standalone AI tools, ChatGPT, Midjourney, Dali, integrated AI tools, Copilot, Netflix, Google Slides, and customized AI tools, right? So one of the example is Spotify DJ, okay, AI. So it is a particular company that basically wants to work on DJ, right? They want to work on a music. So it Spotify has basically made a customized platform for a separate DJ in it. Also, let's say if a company is there, okay, they want to manage its staff and it wants to make a CRM. So in that CRM, according to company's requirement, we have customized and give it to AI. So what is happening in today's date? We have a standalone tool, and then we have integrated AI tools, and also we have customized AI tools. Okay. So basically, these are the important tools of artificial intelligence. Okay. So now we have discussed all these things. So now let's directly get into artificial intelligence, its definition, and let's try to understand that. So what is artificial intelligence? So artificial intelligence is the ability of machine to perform tasks, okay, that normally require human intelligence. Okay. It includes your learning, okay, problem solving, decision making, and language understanding. So AI systems analyze large data sets to detect patterns, make predictions, and improve over time. Okay. Powered by machine learning, AI learns from examples and adapts without needing explicit reprogramming. Okay, so this is artificial intelligence. So basically, like artificial intelligence, it can like machine. It is the ability of machine to perform that normally requires human intelligence. So like what humans can do, human know how to learn. So AI is also learning from your data. So human can interpret, debate. They can basically do logical arguments and all, right. So they have a reasoning capability. So this can also be induced in the machines, right? Humans are capable of solving problem, so a machine can also be made in such a way that they can solve the problem. So human can also understand each other language, right? So creating basically such a system wherein they can understand the language. So for example, I'm talking in English, so you are able to understand, right? So similar way, even machine can also do. Okay, so because you see human can see, okay, the images with their eyes, right? They can hear the sounds with their ear, they can make patterns in their brain. Okay, and then this example, you see if a kid is there, right? uh, if you show the kid the apple, okay, then what happens, the kid makes an image of it, okay, and it makes a pattern in his brain. And let's say if you show him 3 4 times, and then again if you tell him this is apple, so next time, since his brain gets trained, after that next time he himself will start telling automatically that this is apple. Okay, this is how even artificial intelligence uh, works. Okay. Okay, so now let's see some other aspects of artificial intelligence in a more broader way. So, for example, here artificial intelligence, they acquire knowledge from data. Okay, the first point is the learning part, then the reasoning part. So, making logical decisions. Okay, then comes the problem solving part, finding solutions autonomously, and then comes the understanding part, which is comprehending language and context, and then ultimately the perception part, which is recognizing images and patterns. So what is AI? AI is machines mimicking human intelligence, learning from experience, adapting to new situation, and performing tasks that typically require human cognition. So basically it's not a magic, it's mathematics and data working together brilliantly. So this is all about artificial intelligence. Okay, now let's see the evolution of artificial intelligence from dreams to reality. So it basically the birth when it happened. So it's not a new term, right? Artificial intelligence is actually started long back, almost 75 years back. Okay. So at that time, Alan Turing, he initially asked, can machine think? Okay. And then ultimately in 1956, John McCarthy, so he has given the name artificial intelligence. And then in 1980s and 90s, expert system, your rule-based AI emerged. Okay, your computers follow programmed logic to solve specific problem. And also in this time period, there were a lot of other challenges also it has faced because of resource and because of funding and all, which happens with any new technology. But it has overcome, and then in 90s, a big breakthrough has come, wherein IBM Deep Blue Chess, right? It has beaten Gary Kasparov, who was a world champion of chess at that time. Okay, so then at first time, world's attention went to him. Okay, and then people started understanding the potential of artificial intelligence. Then your chat box was introduced, your personal assistant was introduced. Okay, a lot of them, for example, Siri, Alexa, Google Assistant, these all things have come into play. Okay, and then slowly these things started developing. Okay, so Apple introduced Siri in 2011. Okay, and then Cortana into 2014. Microsoft has introduced Cortana. Okay, then comes Amazon. Amazon in 2014 they introduced Alexa, and in 2016 Google introduced OK Google. So this 2010 onwards, there was a machine learning boom has come. Okay, so your deep learning concept, okay, that revolutionized artificial intelligence. Your neural networks achieve superhuman performance in image recognition. Okay, and in 2020, and now we are also seeing is the generative AI era, right? So your chat GPT, it was launched, and bringing AI to masses, creativity meets automation. And in future, you will also see agentic AI. Okay. Okay, then we'll also see the AI evolution from your discriminative to hybrid intelligence. Okay, so the first like one of the oldest type of artificial intelligence which has come initially was discriminative artificial intelligence. Okay, so the artificial intelligence landscape has evolved through distinct paradigms, each building upon the previous to create more sophisticated and capable systems. Understanding these four key types of AI helps us navigate the current technological revolution and anticipate future developments. So, for artificial intelligence, I mean, the first type we'll see the discriminative. AI. Okay, we'll see these in detail with example, but for just from a definition standpoint, let's see each of them one by one. Okay, so first is discriminative AI. That is a traditional machine learning that classifies, predicts based on patterns in data. Okay, so here just take the key terms, key takeaway here. So discriminative AI, it basically what it does, it classifies and predicts based on patterns in the data. For example, okay, the example includes your image recognition, your spam detection, and recommendation system that analyze in existing information to make decisions. Okay, especially your spam detection, right? When email comes which pretty much sounds like your scam and all, right, like your won lottery and other thing, those kind of email, it's been sent to spam, right, and other email is in your inbox. Okay, so this is what it's doing. It is basically classifying based on the patterns in the data. So that is called your discriminative AI. Okay, second is generative AI. Okay, that creates new content by learning from training data. Okay, so they create new content by learning from training data. So this includes large language models like your chat GPT, okay, image generators like your DALI, and systems that produce text, image, code, and other creative outputs. So these are some of the example of generative AI. Okay, then comes agentic AI. These are autonomous systems that can plan, reason, and take actions to achieve goals. These AI agents can interact with environments, make decisions, and execute complex multi-step tasks with minimum human intervention. Okay, so we'll see, as I mentioned in detail, each one of them. The last one is hybrid, as the name suggests, the convergence of all the approaches that we have seen, your discriminative, generative, and AI. Okay, reasoning to create comprehensive AI system that can understand, create, and act intelligently across diverse domains. Okay, so now let's see each one of them with their examples. Okay, the first one is discriminative AI. Okay, okay. So in case of email, what happens, right? In the email, we get the spam filter, right? So for example, we use this email. So in email, we get a mail like, "Congratulations, you have won a lottery." Okay. So the first, I mean, use here is to classify the email. Okay, if these kind of spam kind of thing, we'll put in that spam folder, and other in a regular your inbox. Okay, next is your face recognition. Okay, so they have also started to come in mobile phones, right? So locking and unlocking happens based on your face recognition model, right? Then comes your fraud alert. So when you do internet banking, right? So there you see that there is extra layer of security also happens if you try to log in from other mobile other system. Okay, for internet banking, it goes to your email, or even your mobile also with some number you have to pay. You have to basically enter. So these thing happens to make sure that there's no scam and other thing happens, right? So this is what these are the some of the example of discriminative model, which means that we can discriminate, we can differentiate whether the email is a spam or not. Okay, is the face of the person is same or not. Okay, and the locking and unlocking happens based on that, and the fraud is detection, right? Is the a person doing online banking is same or not. So these discriminative model they have started to develop. Okay, then comes the generative AI. Okay, so these are some of the example famous like your chat GPT, Scribe, Alpha Code, GitHub Copilot, GPT-4 Bard, then your DALI, Claude, Synthesia. So these are some of the example of your generative AI. Okay, so basically what it happens here, it works on the content and data creation, right? So in this, what you do, you give a trained data to the model, and they give the output to us. Okay, so for example, when we talk about the image generation, right, we have this DALI. Okay, then your chat GPT where it generates the text for us, right? And then comes in case of speech, there is a wavenet. Okay, so today we see that people get songs in different voice and all, right? So AI is basically what it is doing. It is generating images in different ways. Okay, so this is nothing but your generative AI. Okay, so in past also we have seen that, I mean, generative AI is there from last 2 3 years, right? Now people earlier used to search anything in Google. So now slowly they are searching, and even we, all of you also, you see in day-to-day life, if you have to do any search and other thing, we are using chat GPT nowadays, right? So after chat GPT and all generative AI, what next? Which is what is going to be the next future? Okay. So the next is your agentic AI. So all the like your CEOs, founders of the company, they are talking about this agentic AI. Okay, Meta, Mark Zuckerberg, he said that AI research has started on agentic AI, basically to enhance it. Google Sundar Pichai, he has also talked a lot about agentic AI and its future. Nvidia, they have said that the era of artificial intelligence has started, and Microsoft has already introduced a new AI agent. So let's understand some of the examples here. As you can see, for example, you see automatic cars, right? This is one of the example of your agentic AI. Okay, so basically what they do, okay, they know how to make decisions. Okay, for example, let's say if I have to decide, okay, between different stocks. Okay, let's say one is Tesla, one is Nvidia. So what should I buy? Okay. So, I mean, on a day-to-day basis, we also make a lot of decision, right? Every day. Okay. What to wear, what to eat, where to go, all this kind of thing. So, a human can think all of these, and even a machine can also think, right? So, for example, let's say if I have a personal AI agent and I want to buy a gadget, then what I'll do, I'll go to this AI agent and he will basically tell me what is better for me. So he'll streamline the process for me and he will do the work from me. And this word agent itself, right? So you take a, just correlate it with your let's say train agent, right? For example, let's say if you have to book a train ticket, so what you do, you give money to the agent, he basically book the ticket and he gives to you, right? So in today's date also AI agent have come. Okay, so as I mentioned, this agent, they give the ticket, they book the ticket on your behalf. So you don't have to do it by yourself. You just give the money, right? So similarly, AI agents will basically develop AI robots which can take decision on your behalf. Okay, they will fulfill the task. As I mentioned, self-driving car will basically automatically take you to the decision. It is one of the example of agentic AI. Okay. Also, AI-powered robots or game platforms and personal exam your assistant. For example, Auto, GPT, Baby AGI, and many other companies are working on it. And I can say that next revolution is of this agentic AI. Okay, and maybe it may take 3 year, 4 year, 5 year down the line, but definitely it is going to happen. Okay, so earlier, as I mentioned, that everyone used to use this Google, and now they are using Chat GPT. So you never know in future. People may start using a lot, and lot of research and other thing would by that time would have happened in this agentic AI. Okay, okay. After this, next comes your hybrid model. Okay, so a hybrid model is, as the name also suggests, it's a hybrid, right? So it's a combination of your, it uses both, right? It can be developed on both your generative AI and agentic AI. Okay, so such models are your hybrid models. So example is your self-driving car itself that can recognize image and they can take also decision. Okay. Okay, then comes the structure of artificial intelligence. Okay, these are the building blocks of intelligence. So as you can see here, as part of the structure of artificial intelligence, we have machine learning, we have deep learning, we have neural networks. Okay, so AI is an umbrella term, right? And machine learning is a subset that learns from data. Deep learning is an advanced ML technique using neural networks. Each layer builds on the one below. creating increasingly sophisticated intelligence. So we will be going through each of one of them one by one with examples. Okay. So, I mean, see, artificial intelligence, this is a final product, right? So, for example, Alexa. Alexa is a final product of AI. But to create a Alexa, there are different technological tools that must have been used, right? So, these are those tools. Okay. I mean, just for an example, you can understand that way. Okay. In that, first is machine learning. So let's learn about machine learning first. So what is machine learning? Machine learning is a subset of artificial intelligence that enables computers to learn and make decisions from data without being explicitly programmed for every task. So machine learning algorithms, what it does, it identify patterns in the data, use these patterns to make predictions or decisions on new or unseen data. Okay, so I mean, let's see some of the examples of machine learning. So first of all, see, machine learning, it's basically a type of technology that allows the computer to learn from the data, right, and make decision without being directly programmed. So in simple word, let's take an example of a child. Okay, the child, as I mentioned earlier also, that is being taught, right, of, let's say, apple. So he has been shown a image of apple from child, and then he basically sees it, and it basically makes a pattern in his mind. And next time when you show the apple, then he automatically tells apple. Okay, so after seeing the photo, image is basically created in his mind, right? So after that, you bring any apple in front of him, he automatically says apple. So inspired by this same concept, this machine learning is also trained a model and basically learn from the data. Okay, so first of all, in this, what you're giving, the main important thing is the data. That is the brain of your machine learning. Okay, and let's say here, for example, so I'm making a model, right, that will basically predict the brand of the shoe of the company. Okay, so first of all, what I'll do, I'll give a training data to that model. So let's say I gave Nike data to the model and trained it. Okay, and also I've given Adidas data and trained it. So now my model will be trained, and going forward, let's say whenever you're giving a new data, once it gets trained, then it will do a accurate prediction. So this is how machine learning works. Okay, in real time, let's say if I have to take an example, then Ola, Uber, or Rapido, right? So if you have to go from one place to another place, let's say from your home you're going to airport or railway station or any more. Okay, so what you'll do, you just give the destination, your current and your current location and your destination, and it basically gives the amount or money which is going to the fare, right, of that. So that is how, I mean, this production the prediction model that works, it works on that prediction model. Okay, and once your model is trained, then it can perform accurate predictions. Okay, so this is about your machine learning. Okay, so now comes the types of machine learning. Okay, very important. This the first one is the supervised learning, then unsupervised learning, then reinforcement learning. Okay, let's see the definition of each of them, and then we'll also see a detailed example. Okay, so supervised learning. Okay, what is this? AI learns from the labeled data. Okay, this is very important. Labeled data, example like showing it thousands of cat photos labeled cat until it recognizes cat on its own. Okay, some of the examples are like email spam detection, medical diagnosis, price prediction. Okay, these are some of the example of supervised learning. Then comes your unsupervised learning. Okay, some what is this unsupervised? AI finds patterns without labels. So here label data is there, is given, and here there is no label data. It's a raw data which is given. So clustering customer by behavior or discovering hidden trends in data. Some of the examples of unsupervised learning are your customer segmentation on anomaly detection and recommendation systems. Okay. Then comes your reinforcement learning. Okay. AI learns through reward and penalties. Okay, like how game playing AIs master complex strategies. Some of the examples are like your AlphaGo, robotics control, self-driving cars. So these are the examples of reinforcement learning. Okay. So coming to the supervised learning, right? Your spam detection, so whether this email is spam or not, your high house prediction, these, and your image classification, cats and dogs, to classify those. So those will come under supervised. Okay. So now let's see the concept of this label data. So let's say it basically what it does, it makes prediction or decision based on the level data, right? So in this, what you do, you keep the label data and then also the input and output. Okay, and the model from inception itself, it knows, okay, and that the which output belongs to which, right? So I mean to say, which input belongs to which output, right? So model, what it does, model tries to understand the pattern, okay, and ultimately, whenever you give a new data, then also it gives a correct prediction. So as you can see here in this example, what we have done, we have given a label data of a carrot, tomato, and bill paper. Okay, this is the label data. Okay, and in this database down, and then ultimately model training has happened here, and once it is trained properly, then it makes the correct prediction. So for example, going forward, if you give in a new test data also, then what will happen, it will do a correct prediction that okay, this is carrot, this is bell pepper, and this is tomato. Okay, so this is what supervised learning is all about. Okay, then comes the unsupervised machine learning. So here what you do, you give a raw data. Okay, it is unlabeled data. So it does not, you don't give a label data here. So basically here what happens, yeah, I mean, since you're giving unlabeled data, right? And the algorithm here, learning algorithm, they are so strong that they will basically do processing, and they will give the correct output, right? They will do a correct prediction, okay, based on that. So this is called your unsupervised learning, and this is the example of it. Okay, and then comes your reinforcement machine learning. So basically here what happens, your agent, they talks with the environment, okay, and they learn through the reward system. Okay, so for example, parents, right? Like how parents tell to the kid, right? That let's say if you pass in the exam, or you do top in this particular exam, then we'll give you gift. Okay, so human works on this reward system, right? So and let's say if it does not perform well, then he gets punishment also. Okay, so if he perform well, then he'll get a good feedback. If he does not, then he'll not get a good feedback. So on the same basis, when the model is trained, right, then it is called reinforcement model. Okay. So, supervised learning, right? What it does, it solves the problem of your classification and regression. So, classification, nothing but you're classifying the email, right? Whether it is spam or not. Okay. Then comes the regression, the price prediction model of Ola or Uber. Like if you give the destination, you're from and to, and then it gives the price prediction based on that. Okay, and then comes the unsupervised learning. It solves the problem of clustering, right? So here you give the unlabeled data, right? So basically it divides it into clusters. So your customer segmentation in the market, this is one of the example of clustering. And ultimately it comes the reinforcement learning. So model take actions in environment and then receive state updates and feedbacks. So these are some of the types of your machine learning. Okay, so now let's understand about deep learning. Okay, so deep learning is basically a specialized subset of machine learning that uses artificial neural networks with multiple layers to model and understand complex data patterns in the data. So deep learning mimics the way human brain process information through interconnected neural arranged in the layer. Okay, so this is what deep learning is all about. So like your human brain, right? It is based on human brain. So human brain is very complex, right? So brain has the ability, right? That basically we react based on whatever we see or how we feel. So for example, you see suddenly a car in the road. Okay, if you're driving, then you immediately brake it, right? Or let's say if you hold a hot glass in your hand, then what will happen, you will immediately try to get away of this, right? So this is how human brain reacts. So basically this deep learning is inspired from this particular thing, uh, and basically here we have deep learning and neural networks. Okay, this is the brain connection of this. Okay, now coming to the neural networks, we'll understand this how it happens in deep learning, but with analogy with this particular example. So you have your dendrites, okay, your cell body in the brain and your axon. So what is the use of dendrite? It basically receives the information, okay, from different neurons. Then basically what it does, cell body, it basically process, okay, the information, and ultimately axon, what it does, it basically gives the output to different other neurons. So on this concept itself, your deep learning has been built on. Okay, there we have this input layer, then hidden layer, and then output layer. So input layer, what it does, it basically receives the information. Then your hidden layer, what it does, it processes the information, and output layer provides the output. Okay, so this is about your deep learning. Then comes the difference between machine learning and deep learning. Some of the key differences are like your machine learning, the broader category of algorithm. It basically includes various techniques like your decision tree, SVM, linear regression. Then comes to your deep learning, it's the subset of machine learning, specifically uses neural networks with multiple hidden layers. Okay, so this is the key difference. Then comes the data requirement. In machine learning, it works well with smaller data set. Okay, it can perform effectively with hundreds to thousands of data points, and it has less data, it is less data hungry. Then comes your deep learning. It requires large amounts of data. It needs thousands to millions of data points, and the performance improves significantly with more data. Okay, so these are the data requirement for machine learning and deep learning. Then comes the feature engineering. So for machine learning, it requires manual feature engineering, and for deep learning, automatic feature extraction. So human must identify and extract relevant features from raw data. And for deep learning, neural networks learn features automatically from raw data. Okay, so this is about the feature engineering for machine learning as well as deep learning. The computational requirement for ML and DL, like your first for ML, lower computational requirement. For DL, it is high computational requirement. It can run on a standard computer, often needs a GPU or specialized hardware. Faster training times, and this is long training times. Okay, so one thing, like if you have to understand a major difference or basic difference, it has huge data, right? And that's the reason you see the hard specialized hardware is required. Here it is relatively less, and it can run on, that's the reason it can run on standard computer. So this is the other difference. Then the examples, okay. Machine learning examples are your spam detection, okay, email spam detection, then customer segmentation, okay, and then sales forecasting, recommendation system. These are examples of machine learning. Then comes your deep learning, image recognition, natural language processing. This we are going to see in future slides, and then speech recognition and autonomous vehicles. So these are some of the example of deep learnings. Okay, so when to use both of them? So machine learning, when you have limited data that I mentioned earlier, need interpretable results or have single pattern recognition task, then we use machine learning. Okay, when we use deep learning, so when you have large data set, complex patterns to identify, or task involving image, text, or speech, then you use deep learning. So the choice depends on you, your data size, computational resource, and problem complexity, whether you want to use deep learning or machine learning. Okay, next concept is your NLP. Okay, so what is NLP? NLP is a broad field of artificial intelligence that focuses on enabling computers to understand, interpret, and generate human language. Okay, so NLP, what it encompasses various techniques and methods for processing text and speech data. So this is the concept of NLP, which is nothing but your natural language processing. So one of the example of NLP is like your Alexa. Okay, so you tell something in Alexa that Alexa tell me about, or play this song, or tell today's news. So they understand the language of human, right? And based on that, it performs actions. Okay, so this is one of the example of NLP. Now, for next model is your LLM, okay, large language model. So LLM is an artificial intelligence based trained on vast amount of text data to understand and generate human-like language. So these models use deep learning techniques to predict the next word in a sequence, enabling them to write, translate, and summarize and answer questions. So LLM is a specific type of AI model within NLP that use deep learning and massive amount of text data to understand and generate human-like text. Understanding how artificial intelligence processes and generates human language through neural networks. So thinking of an LLM as sophisticated pattern recognition system that has read millions of books, articles, and web pages to learn how languages works. So this is about LLM. Okay. So how LLM works, the training process. First is data collection. So it has massive data set of a text from books, websites, and articles, okay, that are gathered. Then comes your neural network training. So the model learns patterns by predicting the next word in millions of text sequence. Then comes the parameter optimization. Billions of mathematical parameters are fine-tuned to improve accuracy. And ultimately the validation and testing. The testing model is tested on a new text to ensure it generalizes well. So this is how the process of LLM works. Okay, then comes the architecture, the transformer networks. So LLMs are built on transformer architecture, which uses attention mechanism to understand relationship between words in a sentence, regardless of the distance from each other. Okay. Okay, so next, see some of the simple examples. So for example, let's say if the input is the weather today is, so next will be, so LLM processing, we have this analyze context and pattern, then consider probability of different words, and then select most likely continuation. Okay, so there can be different possible outcomes, right? Like the weather today is very sunny, 45%, okay, uh, cold, 25%, nice, hot. So basically, this is how the prediction model works. Okay, then some of the key components of LLM. Okay, like your token, embeddings, attention layer, and parameters. These are the some of the key components of LLM. Okay, popular LLM examples like your GPT-3, Palm, Llama, and GPT-4. Okay, these are some of the LLM examples. Okay. What LLMs can do? It can help in this text generation, create articles, stories, emails, and creative content from prompts. Okay, prompt is nothing but your command, right? Then translations. Okay, convert text between different language with high accuracy. Question answering, like provide detailed response to complex questions across various.
topics. Code generation, write and debug programming code in multiple languages. And summarization, you condense long documents into key points and main ideas. And ultimately, creative tasks, you generate poem, script, marketing copying, and brainstorm ideas. So these are the things which LLM can do. Then what are the limitations and challenges? First is your hallucinations. So may generate plausible sounding but incorrect information. Then comes your training data cutoff. Knowledge is limited to information available during training. Then computational cost. So requires significant computing resource to train and run. And ultimately bias and fairness, so can reflect biases present in the training data. So these are some of the limitation and challenges of LLM. What are the future of LLM? So LLM model represented fundamental shift in how we interact with computer and process information. So as they continue to evolve, we can what we can expect. We can expect more efficient architectures, require less computational power. We can expect a multi model capabilities. Okay, combining text, images, and audio. We can basically expect a better reasoning abilities for complex problem solving, and finally specialized model for specific industries and use cases. So LLMs are not just the tools, they are becoming collaborative partners in human capability, creativity and productivity. Okay, then comes the difference between LLM and NLP. So NLP, the field teaching computers to understand, interpret, and generate human language from simple spell check to complex conversation. Okay, so everyday use we use like say in voice assistant. Okay, like Siri or Alexa, we use NLP. And then translation apps, sentimental analysis, chatbot, autocomplete suggestion. So these are some of the examples of NLP. Okay. Um, so here the keyword again here is to understand, interpret, and generate human language. Then comes LLM, so massive neural network. It is based on neural network, right? On enormous text data set, billions of parameters of learning language patterns, context, and meaning. Some of the examples are like your Llama, Palm, Claude, GPT-4. So these powerhouses houses can write, code, analyze, and reason using language in remarkably human-like ways. Okay, so next is the key relationship. We have to talk about NLP and LLM key relationship. So the first is this the broader field. It is a broader field, and LLM is a specific approach within NLP. Okay, it includes all language processing techniques. It uses transformer architecture and large scale training. So think this way that NLP is an entire toolbox, while LLM is one powerful tool inside the toolbox. Okay, so this is the key relationship between NLP and LLM. Next is some of the examples of NLP. Let's see. First is a sentimental analysis, determining if a review is positive or negative. Next, name entity recognition, identify people, places, and organization in text. And then comes your machine translation, converting the text from one language to another language. This is also one of the example of NLP. And ultimately, this speech recognition, converting spoken words to text. So these are some of the example of NLP. Okay, LLM example, your chat GPT, your conversational AI that use answer questions and generate text. Okay, then your GPT-4 advanced language model for various text generation tasks. BERT, this is a bidirectional model for understanding context in text. Then your cloud AI assistant capable of complex reasoning and analysis. So these are some of the example of LLM. Technical differences, we'll quickly see the NLP approach, rule-based, statistical, machine learning, deep learning, and hybrid. LLM characteristic, your transformer, billions of parameters, pre-trained, massive data sets, fine-tuned for specific tasks and emergent capabilities. Simple analogy, if I have to talk about LLM and NLP. NL, NLP, just think like it's like a kitchen. Okay, kitchen basically it contains all the tools, techniques, methods, right, for preparing language-based dishes. And LLM is like a high-end blender. Okay, it is a powerful appliance in that kitchen, and that can handle many complex work, right? The task. So this is one of the analogy between LLM and NLP. In If I have to summarize it, NLP is the field, LLM is a method, and both work together. It encompasses all method for computer language processing. Okay, and LLM is a specific, powerful approach within NLP using large-scale neural network. LLM represents the current state of the art in many NLP applications. Okay, so this is the summary. Uh, Finally, uh, last we'll cover this computer vision. So computer vision, it's a teaching computer to see and understand visual information from world around us. Okay. Computer vision is nothing but teaching computer to see and understand visual information from world around us, right? Um, so computer vision is a field of artificial intelligence, okay, that enables computer to interpret and understand the visual information from digital image or videos. So just like humans, they use their eyes, the brain to see and recognize objects. So computer vision systems can they use cameras and algorithm to analyze visual data and make sense of what they are seeing. Here the goal is to automate tasks that human visual system can do, identifying objects, understanding scenes, tracking movement, and extracting meaningful information from visual inputs. So one of the classic example if I have to take is the self-driving car in case of computer vision. So in self-driving car, we don't have any driver, right? So it knows by themselves that where exactly they have to go, and if let's say if there's some hurdle in front of him, let's say some person comes, so it knows how to basically take care or basically these hurdle, how to pass these hurdles, right? So basically see human can see, right, if there is some hurdle comes. So in similar line your machine can also see. So in this the image and the video data, okay, they are being trained. Okay, so this is what computer vision is all about. Then how computer vision works. So it works on image acquisition. Your camera or sensor captures a digital image or video, then pre-processing, clean and enhance the image data for analysis, then feature detection. You identify important patterns, edges, and shapes. Analysis and recognition, use algorithms to classify and understand object. Decision making, take action based on what was detected. Okay, so this is how computer vision works. Then some of the key technologies behind computer vision, like your machine learning, deep learning, and image processing. So machine learning algorithm that learns patterns from training data to recognize object uh, and basically these scenes, right? For deep learning, neural networks that mimic human brain processing for complex image recognition, and then ultimately the image processing, the mathematical operations to enhance, filter, and transform digital images. Okay, so these are some of the key technologies behind computer vision. Okay, some real world examples like your autonomous vehicles, self-driving cars, as we already discussed, they use computer vision to detect pedestrian or read traffic signals and navigates roads safely. Okay, then comes your facial recognition, smartphone and security system identify individuals by analyzing facial features, right? And finally, the medical imaging, it is also used there. So, doctor use AI to analyze X-rays, MRIs, and CT scans to detect diseases and abnormalities. So, these are some of the real world examples of uh, this particular computer vision.
A simple example of this object detection. So in this example, let's say computer vision system takes an image of a dog as an input, extract important visual features like edges and shapes, and process them through a trained algorithm and outputs the classification. So dogs with a confidence score. The challenges in computer visions are like your technical challenge. For example, first is your varying lighting condition. Okay. Then different angles and perspectives, then object blocking each other, this occlusion. So these are some of the technical challenge, and finally this image quality and resolution. Some of the practical challenges is large amount of training data needed here, computational power requirements, privacy and ethical concerns, and real-time processing demands. So these are some of the practical challenges for computer vision. So the future of computer vision is rapidly advancing with improvements in AI and processing power. The future application will include more sophisticated augmented reality experiences, better medical diagnostics, smarter cities with intelligent infrastructure, and seamless human computer interactions through gesture and emotion recognition. So, this is the future of computer vision. So, with this, we have covered the basic of artificial intelligence. So, we have covered a lot of things like your tool. Okay, first we have covered the different types of artificial intelligence. I just mentioned type. Then your tools. Okay, I just mentioned TO. Then the structure. Okay, that basically includes your ML, machine learning, and there are three types of machine learning also we have seen. Okay, supervised, unsupervised, and your reinforcement. Okay, then we have also seen in the structure of architecture as your deep learning, which is based on your neural network. Then NLP, okay, natural language processing. One example you can take as Alexa. Then computer vision, okay, your self-driving car. So these are the structure of your basically uh, artificial intelligence that we have seen. We have seen the types and also the different types of like your tools of artificial intelligence. So just go through the session one more time. You'll get the complete clarity. We try to cover each and everything in a very simple and plain manner. I hope you guys have enjoyed the session. So all the best to each and every one of you, and we'll meet again in the next session. Thank you so much and catch you guys later.